Okay, so now that you have seen that section and how that's supposed to look, you can answer questions 2 through 7 of your lab manual. So those are going to be the first questions on your quiz online. The submission will be similar to how we have done the last few labs, and I'll show you that after we go through this part. So the first question is, what formations is the groundwater located? So that I've already told you, and also you can see it in the remarks lithology section of the log sheet, so on item 13. You can see where water is present and where it's not. So that will be a multiple answer question on the quiz. Question 3. Is this aquifer confined or unconfined? So is infiltrating water prevented from moving downward or upward for that matter? So that will be a multiple choice question on the quiz. So what do you think? Can the water move upward? Can it move downward? Is it completely confined? It can't go either. What is it? Okay. Question 4. What formation makes an aquitard or an impermeable layer that forms the bottom of this aquifer unit? So based on what I've told you and what you saw in the diagram and what the lithology says on item 13, you'll be able to say what it is. Okay, so number 5. Farm B is thinking about getting into the dairy business and would like to install a settling basin that would hold their cattle waste. This will ultimately infiltrate into the groundwater. So should Farm A be concerned? So here he gives you a hint. Which direction is the groundwater flowing? So you have to think about groundwater flow. Does the water flow downwards or upwards? So hopefully you're thinking that it flows downwards. So remember to look at the static water level for either well, and whichever one is higher, the water is going to flow towards the one that is lower. So basically that's relatively straightforward. So in that sense, will the Farm A be concerned or not? Okay, so question 6. What is the hydraulic gradient, meaning the change in elevation over change in distance of the aquifer from west to east? So here, because the hydraulic gradient is unitless, you have to convert the amount of miles to feet. So here he's giving you 1 mile is equal to 5280 feet for the distance part. So the change in head, delta here means change, is equal to the hydraulic head, meaning the location of the static water level at one place, minus the H2 or the head at the other well. Okay, so you're going to subtract that location, that static water, from one location to the other. And then you're going to divide that by the distance between the two locations. And that distance, again, has got to be in feet so that this can be a unitless number. So here your answer, I think this is a multiple choice question. As you'll see, it will be like a 10 to the minus something. Your result will be something like that. So don't be concerned if it's a really small hydraulic gradient. And that makes sense, right? The gradient itself is just going to be, again, a change in elevation over distance. And because water, as you saw, goes from only a few feet to another few feet over 3 whole miles, the gradient itself is very, very, very shallow. So it still flows, it still has a downward and an upward direction, but it's not a 30 or 45 degree angle. It's relatively small, so it flows slowly. Okay, lastly, what will someone pumping from well A most likely, will someone pumping from well A most likely affect water levels in well B? So here I'm going to have you think about this question on your own based on what we saw in lecture. This is a short answer question on your quiz. So you actually have to input whatever you write in your lab manual thoroughly. So think about it well and then go ahead and write it as a short answer. Okay, so I'm going to skip through these because we already talked about them. And we're going to go onward to part B. Okay. Before we go to part B, I want to show you how the submission of the lab quiz will be. Alright, so as you should be used to by now, again, your labs are going to be under the shell lab part of the course. And you're going to go to topic modules, Sp20. And within there, this lab is groundwater. So once this Continues to load. We'll go to Groundwater Chapter 14. So within there, you have 3 links that are important. The first one is the instructions for completing the groundwater lab. It's the same as usual. Here, the most important part is to watch this video, or this set of videos, to know that the submission of the lab is due on Sunday, May 3rd at midnight, okay? And to know that I am there to help you if you need any help. Okay, so the submission itself is done through this quiz. And then below you have all my lecture videos in case you haven't watched them yet and you need to get some reinforcement on the concepts. So the quiz itself, you have 60 minutes to submit it. So that's not going to give you enough time to just look at the quiz and then start the lab. So you should do the lab in your lab manual prior to doing the quiz online, okay? Otherwise, you're not going to have enough time. This is a quiz that doesn't let you exit out of it, so you have to complete it once you start it. So how it looks, it's like this. So the first question, as I said, corresponds to question 2. Here I tell you that. So for this and the next 5 questions until question 6, which in your lab manual is question 7, use the diagram geologic cross-section that I made in the intro video to help you answer those questions. So that is the one that I was referring to some time ago. Okay, so here are those questions until question 7 in your lab manual, which is really question 6. That's all of part A. Cool, so now we go on to part B. Let me go with you. Okay, so part B is asking questions about the groundwater levels within the Snake River Plain. So here they're asking you about two different aquifers, the Bruno geothermal aquifer and the Nampa shallow aquifer. So both of those are, or the data from both of those are shown here on the graphs in page 124, so right above it, okay? So it's relatively straightforward, this part. I think is the easiest of the 4 parts that you have to complete for this lab. So I'm not going to go in depth about that. The questions in the quiz are relatively simple too. I think you do have 2 short answer questions, but I don't think they're too hard. So let's go through these in the quiz so I know what to tell you. Okay, so question 7 in your quiz, which is really corresponding to question 8, so the first question for part B, it's asking you about the water levels in either aquifer. So what is happening to the water levels over time at either aquifer? So based on those observations of the previous 2 graphs, you tell me. Question 9 says the Nampa area irrigates with both surface water during the irrigation season and with groundwater. The Bruno Valley irrigates only with groundwater. So how will this affect the water levels? Or how is this affecting water levels based on those 2 graphs that you have? Okay. Question 10. Notice that the water level in each well goes up and down every year. So what causes this variation? And here I ask you to choose the most likely explanation, because all of these could potentially be influencing it, but what is the thing that really makes sense to go up and down every year in a cyclical manner? Okay. Question 11. Starting in 1995, the Bruno area has experienced a relatively steady decline. What is the rate of water decline in feet per year? So you know that you have some sort of rate at which water is lowering or maybe rising every year. So you have to use the amount of feet that it has decreased or increased over the time span that that graph is given to you, okay? And then this is going to be a numerical answer. So you input some sort of number. Okay, and you have a range of options, or not a range of options, but rather there's a range that I input as to how far or close you can be to my answer. Okay, here, this one is, you have 2 or 3, what did I say? What are the 2 factors that could cause water levels to rise in the Bruno aquifer? So after you look at this whole question, you'll understand this is a multiple answer question, so you could answer 2 of them. Okay, so now question 12 on your quiz is really corresponding to the first question, or the first set of questions from part C. So let's go back to that. So that's the end of part B, relatively straightforward. Okay. So again, end of part B, we go on to part C. So part C is probably the hardest of all. So here especially, I think is going to be the most useful to pause this video as you go along doing this part of the lab. Okay, so I'm going to help you in order for you to be able to construct whatever you need to do on figure 5. Should be figure 5, okay? Okay. So examine the map on the next page. Again, that's figure 5, page 127. The map shows a neighborhood where each house is on an independent well, a creek, and some surface features. In addition, the map shows the depth to water in centimeters measured in each well. So there are several measurements of how far those wells touch water. So in addition, to keep this problem simple, we will assume that the land surface is flat. So we assume land surface is flat. Okay, that's good to know. Now we only have to deal with how the water level is at each of those locations. So this part that says, or this question 13 and 14, they're kind of merged in the quiz to being one big question, but we'll go through this. So first, you have to construct a contour line, construct contour lines for the surface of the water table in intervals of 5 centimeters. So they're giving you an example of a 210 centimeters line, a 205 centimeters line, a 200 line, then the next one will be 195, 190, so on and so forth. So don't forget that this is a measurement of the depth to water table. So a higher number indicates a lower water table. Meaning, because 0 means at the land surface, if I am 5 centimeters below, that is less distance than if I am 10 centimeters below. Okay? So that's what he means by the higher number indicates a lower water table. Makes sense. Okay, so do this by connecting areas of equal water elevation. Remember to label the elevation of your water table topographic lines. So these lines of equal elevation of the groundwater, they're called potentiometric lines, and he refers to them in that way later on in the lab. So I'm going to teach you how it is that you do that. All right, so you are going to use, this is an example. So this is a hypothetical map that has flat surface. So all of these measurements that you're seeing here are measurements of how far below you encounter water levels, okay? So as you're seeing, it is increasing towards the right side. So meaning that the water level is really close here on the left, and or my left, I think it is your left, and then it's getting lower and lower as you go towards the right. So now how is it that you're going to be able to draw the water lines per se? So in this particular map, I'm going to draw the potentiometric or the contour lines for the water level every 2, let's call them meters, okay? So if I want them every 2, I know that 0 is somewhere over here. I'm not going to draw that one. So the first one that I'm going to draw is the number 2 topographic or potentiometric line. So I know that number 2 has got to be further than 1.8, but before 3.7, closer to 1.8 though. So it's going to go somewhere around here. If I take it over here, I know that 2 has got to be to the left of 2.2 because it's less than 2.2. So my line is going to do something like this. And then I know that it's going to go in between 1.7 and 3, a little closer to 1.7. So my line at the very least has got to do something like this. Right? Okay, so let's see. Okay, so that's pretty much what I have. Okay, the next line, which should be line for number 4, will go further than 3.7, right? So somewhere around here. Closer than 4.2, sorry, because it's less than 4.2. And somewhere in between 3 and 4.6, probably a little bit closer to 4.6 than to 3. Let's see. Okay, which makes sense.